Welcome to the unknown.
Imagine for just a moment that you are approaching something in space. The closer you get, the more you don't see details. You see nothingness. No light, no color, no reflection. Just complete darkness. This is not an ordinary empty region of space. This is something far more powerful called a black hole. A black hole is not a real hole, as many people imagine it, but rather a region in space that has such an extremely strong gravitational pull that nothing can escape it, not even light itself. Yes, light, which travels at 300,000 kilometers per second, cannot break free from it. But how does this terrifying thing form? Scientists believe a black hole begins when a massive star dies, one much larger than our sun, sometimes dozens of times bigger. When this star runs out of energy, it collapses on itself in a catastrophic way, compressing all its mass into an incredibly tiny point smaller than an atom, yet with enormous mass. At this moment, a black hole is formed. The gravitational force here becomes insane, to the point where it warps space and time around it. If you get too close to a boundary called the event horizon, you enter the point of no return. From that moment on, nothing can escape. Not rockets, not signals, not even light. Everything gets pulled inward, slowly or quickly depending on how close it is. As you approach further, the laws of physics as we know them begin to break down. Even time behaves strangely near this region, as if it slows down in an unnatural way. But the question that still puzzles scientists today is, what is inside a black hole? No one knows for sure. Some theories suggest that at the center there is something called a singularity, a tiny point with almost no size, but containing all the black hole's mass, where the laws of physics completely collapse. And somewhere in our galaxy, there is a supermassive black hole with a mass equivalent to millions or even billions of suns. This cosmic monster doesn't just swallow stars, it distorts the very fabric of space around it. And yet the most terrifying part is this: we still don't fully know what happens once you go inside. But scientifically, what happens around a black hole is not just a simple falling process. We are dealing with one of the most extreme regions in the known universe. The first important feature is that a black hole does not instantly swallow everything. Instead, it often forms what is called an accretion disk around it. This is a spinning disk of gas, dust, and even shredded stars moving at extremely high speeds, heating up to millions of degrees and emitting powerful radiation that can be detected from vast distances. These emissions are actually one of the main ways scientists detect black holes, since the black hole itself emits no light at all. From a physics perspective, as you get closer to the event horizon, something extreme happens. The difference in gravitational force between 2 points becomes enormous. This creates what is known as tidal forces, which are responsible for the spaghettification effect, where an object is stretched in one direction and compressed in another. Even more fascinating is how gravity affects light itself. Near a black hole, light no longer travels in straight lines as we normally observe. Instead, it bends dramatically due to the extreme curvature of space-time. This is why scientists can observe a distorted glowing ring around some black holes, known as the photon ring. Inside the event horizon, however, known laws of physics begin to break down. Einstein's general relativity describes gravity extremely well, but at the singularity, it fails. To fully understand what happens there, scientists would need a unified theory that combines gravity with quantum mechanics. something we still do not have. This leads to one of the biggest mysteries in modern physics. Does information get destroyed inside a black hole, or is it somehow preserved? This is known as the black hole information paradox, and it remains unresolved. In the end, even though we cannot directly see inside a black hole, we can study its effects on surrounding stars and gas. This has allowed scientists to confirm the existence of supermassive black holes at the centers of galaxies, including our own Milky Way. But despite all scientific progress, one question still remains unanswered. What truly happens inside a black hole?